Hey there, for this problem, it says that the figure shown above is the graph of the piecewise function f. For the interval from -4 to 12, the function g is defined to be the integral of f. So, first part asks us to determine if g has a relative minimum, a relative maximum, or neither at x equals 10. So there's x equals 10. So we can see that g, in order to figure out if it has a minimum or a maximum or neither, we're going to have to analyze g prime. So notice that g prime of x, by the fundamental theorem of calculus, will be f of x, because the derivative of g is going to be just f. It would be the derivative of an integral of f, which would just be f. So then, if we were to draw a quick number line, we can see for sure that at 10, that f of 10 is equal to 0, but when we look to the left of 10, we have negative results, and when we look to the right of 10, we also have negative outputs. So that means that our graph is going downward and downward. The g graph is decreasing, and then at 10, it levels off, but then after 10, it decreases again. So we would say neither, since g is decreasing both before and after 10. So it's neither a minimum nor a maximum. Okay, let's see what part B says. B asks, does the graph of g have a point of inflection at x equals 4? So a point of inflection would be the second derivative of g, which, as discussed in the first part, since g prime is f, that means that g double prime would be f prime of x. So at x equals 4, we're located right there. That is a point on the graph, right? Because the derivative here, the derivative, which is f, is actually continuous, so it's all fine in that kind of sense. And notice that before x equals 4, I was pointing at the wrong spot though, over here. Before x equals 4, f is increasing, so f prime would be bigger than 0, and after x equals 4, f is decreasing, so f prime would be less than 0. Thus, at x equals 4, f double prime changes positive to negative, and so x equals 4 is a point of inflection. So that's the conclusion to that part of the problem. Okay, moving on. Part C asks us to find the absolute minimum and absolute maximum value of the entire function over the interval from -4 to 12. All right? So for that problem, we're going to have to go on the interval from -4 to 12 and figure out when do we have potential critical numbers. So C, on the interval from -4 to 12, we have zeros at -2, 2, 6, and 10, and then the derivative, since this would be g prime, which would just be the f, we can see that we're negative, and then positive, and then positive, and then negative and negative. So overall, the function is decreasing, increasing, increasing, decreasing, and decreasing. So the only real critical numbers we have to worry about are right here at -2, and then right here at 6, and then potentially we have to check the end point at 12, and then the end point at -4. But those 4 values will be sufficient for figuring out whether the graph has minimums or maximums at the different places. So, let's start that off. Okay, g of -4 is equal to the integral from 2 to -4 of f of t dt. All right, so that would be the same as the integral from -4 to 2 of f of t dt with a negative sign. So looking at our graph, it looks like from negative 4 to negative 2 and negative 2 to positive 4 are going to cancel each other out because one of them is negative area and one of them is positive area, but they're symmetric triangles. Going for that last little bit then to 2, we can see that we have a base of 2 and a height of 4. 4 times 2 is 8. Divided by 2 for the triangle is 4. So g of negative 4 equals 4. Okay, next, g of negative 2. G of negative 2 is equal to the integral from 2 to negative 2 of f of t dt, which is the same as the opposite of the integral from negative 2 to 2 of f of t dt. And looking at the graph, from negative 2 to 2, this is now area that is all above the axis. All above, I forgot to put a negative sign in front of that one, sorry. It's all above the axis, and so the area would be 4 by 4, which is 16, divided by 2 is 8, which would be negative 8. G of the next critical point happens at 6, would be the integral from 2 to 6 f of t dt. And from 2 to 6, this is all above the axis also. 4 by 4 is 16, half of which is 8. So that's 8. And then finally, the last little bit would be g of 12, which would be the integral from 2 to 12 f of t dt. And I've already accounted for the value that's getting me up to 8, so all I need to do is add on the last little bit here. So let's go see, actually, from 2 to 12, this part and this part would cancel each other out. So we just have a little bit more negative area that has a base of 2 and a height of 4. 2 times 4 is 8, divided by 2 is 4, and this is below the axis, so it is negative 4. So absolute minimum at x equals negative 2 is negative 8, and absolute maximum at x equals 6 is positive 8. And that's how we'd conclude this problem. Okay, last part, part D. For negative 4 to 12, find all intervals where g of x happens to be negative. Okay, we already did this part right here, which found that we decrease, increase, decrease, and decrease. And now we're trying to figure out where does g of x actually equal to 0. Well, first of all, notice that g of 2 is the integral from 2 to 2 of f of t dt. And so the integral over any finite error between any 2 points, top and bottom bounds being the same, is going to be 0. So that's one place where you're definitely equal to 0. Also, at 2, we decrease before that. So our graph is going to be something like, let's see, g of negative 4 is equal to negative 4. Then we decrease to g of negative 8. Sorry, g of negative 2, which is negative 8. Then we increase all the way up until 2, where we are equal to 0. And then g of 6 is equal to positive 8. Then we start to decrease again. G of 10 cancels out the area that was added on, so g of 10 is going to be equal to 0. And then finally, it keeps on decreasing from then on, so g of 12 is equal to negative 4. So when are we officially less than or equal to 0? We are g of x, we have g of x less than or equal to 0 on the interval from negative 4 up until 2, and also from 10 up until the end. which is 12.